Hello everyone, I'm Dominus Orbis, and today I'll be doing Packet Tracer 7.1.2.4, configuring VPNs, virtual private networks. A VPN needs a gateway. Not just a regular router, but a router that allows the traffic in or out. Now, what are the benefits of setting up a VPN? Obviously, for the teleworker, it costs scalability, can use the public internet, and it's secure. Talking about a couple different things in this packet here. In this packet tracer, you got a GRE, generic routing encryption. It's a tunneling protocol that encapsulates layer 3 packets. So pretty much all layer 3 packets can be encapsulated within the GRE protocol and transmitted over network layer. For VPNs, there's mainly two kinds. You have a site-to-site, which is like a dedicated lease line when the end users have no knowledge of the VPN connection, and it connects entire networks. So there'd be a VPN gateway on both ends of the link, connecting to remote offices, for example. And then you have remote access, which connects individual hosts over the internet. And you usually need client software, like Cisco AnyConnect, or a web-based application. Just going to your web browser using SSL, secure socket layer. Also, we have, talking about here, IPsec. This is a framework of open standards. It's not a protocol, just a framework. It's all open. When we're talking about IPsec, we normally use an acronym CIA for confidentiality. That's going to be our encryption protocols. Data integrity, how to make sure that the data doesn't get altered. Authentication, how do I know that it's from the source that's supposed to be sending it. And anti-replay protection, kind of like just a checksum to prevent duplicate packets. And then the encryption, there's the two kinds of encryption. We have symmetric versus asymmetric. Basically, symmetric, both ends of the link use the same key. It's a shared key. They both know about it. Asymmetric uses different keys. So the key on router 1, for example, would be different than the key on router 3. And then we have, how can we exchange the keys over the internet without a packet sniffer like Wireshark going in there and looking at the data? Well, we have the Diffie-Hellman key exchange. Some protocol. It's a non-encryption. It just protects the exchange, the transport of the keys over the internet. And then we have integrity, using hash algorithms. Basically, the hash algorithm, just to plug in a key into an algorithm, and it has a fixed digit outcome. So I'm going to transmit that hash over the link to the remote router. That remote router is going to take my hash. It's going to run its own integrity check using the same algorithm that I used with his own key. And if he gets the same hash or message digest, then he knows that it's a valid sender, and then he'll go ahead and opens up the packet. And then last but not least, we have authentication using pre-shared key, or RSA is the name of the three guys that invented the protocol, signatures. So I know it's a lot to take in, but honestly, we're not going to see too much of this on the CCNA at all. Maybe just this question here. What is the benefit of a VPN? You will see that question, but you will have no configuration commands. So pretty much just have to follow the instructions. In this activity, you will configure two routers to support site-to-site IPsec VPN for traffic flowing from their respective LANs. The IPsec and VPN traffic will pass through another router that has no knowledge of the VPN. IPsec provides secure transmission of sensitive information over unprotected networks such as the internet. IPsec acts at the network layer, protecting and authenticating IP packets between participating IPsec devices, peers, such as Cisco routers. This is actually something pretty cool that I didn't know that we could do until this packet tracer. We're going to activate the security module technology package in the Cisco router. So, what does it say here? On R1, here's the package that we're going to activate. Have to accept the terms of service, the end user license agreement, do a write, do a reload. There we go. We're going to do a show version again, make sure that we're on the evaluation profile for the security K9. And it has been activated. There we go. Now we need to do the same for R3. Security package has not been installed, or activated, I should say. Okay, it's been activated. Let's go ahead and look at what we got to do next. Configure IPsec parameters on R1. Ping from PCA to PCC. And that packet's getting through. Got to configure an ACL. 110 to identify traffic from LAN on R1 to LAN on R3. That's interesting. In other words, the router is going to take notice of it when determining whether or not to allow it through. This traffic will trigger the IPsec VPN to be implemented whenever there's traffic between R1 and R3. So pretty much we want these guys to be able to talk to these guys going through R2 without R2 knowing what that data is. Hence the tunnel right here. Alright. Now the crypto sets the encryption module. So okay, so I went ahead and defined some of these acronyms here. This ISAKMP is the Internet Security Association and Key Management Protocol. And then the AES is Advanced Encryption Standard, Symmetric or Pre-Shared Key. And then we have an encapsulating security payload with the triple DES, which is the Data Encryption Standard, Symmetric Encryption. Also, we're going to be using the SHA, Secure Hash Algorithm, Cryptographic Hash Function. And HMAC, which is the Keyed Hash Message Authentication Code, which calculates a message authentication code using a hash function and a secret key. Combination of a public and a private key, for example. So I'm just going to continue where I left off here using the crypto IPsec transform set. Define transform settings. Okay? Now we need to name it. VPN set. I'm going to enter a map for that now. You know what? I skipped over some steps. Let's start over. This is the Diffie-Hellman. Remember, that's how the keys are exchanged. It's not an encryption. And I'm going to set my key. So it's important to know who I'm sharing it with. 10222. That's router 3. Serial interface 001 should be this guy here. Yep. Okay. Configure the crypto ISAKMP policy 10 properties on R1 along with the shared crypto key. Cisco refer to the ISAKMP phase 1 table for specific parameters to configure. Default values do not have to be configured, therefore only the encryption key exchange method and the Diffie-Hellman method must be configured. You don't really need to look at this at all because this packet tracer actually tells you step by step every single command. The reason being is, once again, I reiterate, on the CCNA exam, you will have no VPN IPsec configurations. And I only encountered one question, which is what are the benefits? The cost and scalability were the answers. So all that other stuff is just a FYI for your information. Alright, I already did step 3, step 4. Create the transform set, use ESP triple DES, ESP SHA HMAC, then create a crypto map that binds all of that phase 2 parameters together. Use the sequence number 10 and identify as IPsec ISA map. Let's get started. I'm going to go ahead and reissue the commands that I was doing. I got sidetracked researching those acronyms. You will actually be learning more about those if you take the CCNA security. So don't worry. If you want to get more into depth into cryptographic hashing and ACLs and stuff like that, IPsec, you should really take the CCNA security. Setting up who I'm going to share this pre-shared key with. Binding my transform set. And matching the ACL. Next, bind the VPN map, crypto map to the outgoing serial interface. This is not graded. But for it to work, we need to go and do that. Now we're going to configure IPsec parameters on R3. We're pretty much going to enter in the same commands. Here we go. Create our access list, which will allow the R1 LAN traffic on my tunnel. I think that's it. There we go. Diffie-Hellman group of 2. Set my pre-shared key with the R1 serial. We're pretty much done. Set the transform set, name it a VPN set. Set up my encryption protocols, triple DES, ESP SHA with the HMAC. Make a map. Highly encourage you to read some of the white papers, the Wikipedia, the Neticat content over these protocols, these hash functions, etc. It's very interesting. Matching the ACL. Now I should be able to ping. Verify the tunnel prior to interesting traffic. Packets encapsulated, 0. Packets encrypted, 0. Packets decapsulated, 0. Packets decrypted, 0. Alright. Let's go ahead and produce some interesting traffic. Let's give that a second there. As you can see here, it went through. Let's reissue the shell crypto IPsec SA. Only 3 of the pings got through, right? So only 3 of them were encapsulated, encrypted, decapsulated, and decrypted. Let's do it again. Should be 7 now. It even tells you about your transform set here. Your crypto map name. The lifetime of the key, which you can modify. Where the endpoints are of the tunnel. The permit flag, the origin is ACL 110. I got a send error because one of those packets timed out due to ARP. What else do we got here? This is inbound here, and this is outbound. Pretty much the same thing, using a tunnel, right? Let's reissue it now. Got 7, just like I said. Okay. Now I'm going to create uninteresting traffic. In other words, PCB from PCA. We got to look at that. We didn't do anything about here. So the VPN should not keep track of those packets. Let's check it out. Here it goes. 3 packets got through. 1 fell due to ARP. Should still have 7 here. And we do. As I'm sure you could hear, my dogs are getting excited about something. So I'm going to go ahead and end this packet tracer video walkthrough because we finished all the commands and we went into some detail. So, once again, my name is Dominus Orbis, and I hope this video has been informative, and I want to thank you for viewing. Have a good evening.